Hello, everyone. Welcome. I'm Professor Nguyen, and welcome to Organic Chemistry. And today we're going to be looking at just a quick study on organic compounds, carboxylic acid, ester, amine, and amide. Okay. The carboxylic acid has double bond O with carbon and OH. Okay. That's the functional group carboxylic acid. The first one, the simplest one, is methanoic acid, also known as formic acid. That's one carbon, just the functional group carboxylic acid, and of course it needs a hydrogen to make carbon 4 bonds. Okay, ethanoic acid is the second one. Instead of hydrogen, you got a methyl, also known as acetic acid. That's active ingredient in vinegars. Okay, going for the next one with more carbon, we got propanoic acid with 3 carbon, 1, 2, 3, and two different way to draw the structure, the condensed way and the line formulas, 1, 2, 3. Okay, and you keep going, 4 carbon, butanoic acid, 5 pentanoic acid, so on and so forth. If you have a benzene with carboxylic acid, we call that benzoic acid. And here's a 4, 1, 2, 3, 4. That's butanoic acid. In addition to that, notice that the carbon of the COOH is always number 1. Okay, that's the most important functional group here. So we got a methyl, so that's a 2-methyl butanoic acid. Here we have 6, 1, 2, 3, 4, 5, 6. And we have 2-methyl, 2, 4. CH3 is methyl. And that's what we call a 2,4-dimethyl hexanoic acid because it's got 6 carbon. We got a benzoic acid. That's automatically number 1 because it's got the COOH. And you got 3-nitro. Nitro is NO2. 3-nitro benzoic acid. Very nice, right? OH is hydroxy. Okay, that's what we call 2-hydroxy benzoic acid. Here we have a 5-carbon, 1, 2, 3, 4, 5. And we got a 3-chloro. Cl we call it chloro, by the way. And that's 3-chloro pentanoic acid. Okay, now ester is a carboxylic acid with no hydrogens. Instead of hydrogen, we put a branch there. So that's why we name the branch, and then we name the carboxylate, and it becomes carboxylate. Okay, so for example here, on the right side, you got to see the oxygen there. That's a methyl. On the left side, that's a 1, 2, 3, 4. We call that a butanoate. That's an ester. Okay, so that's methyl butanoate. So the name of the ester is always 2 parts, the branch and the ester. And the ester is always O8. Okay, isopentyl right here. This is isopentyl. Acetate. Acetate is on the left side, right there. The name acetate comes from acidic. Okay. All right. And that's just for fun. It's from banana oil. That's from pineapple. It's pretty cool stuff. All right. So how do we come up with that 8? If you have 4 carbon, 1, 2, 3, 4, that's butanoic acid. It becomes butanoate if you take that hydrogen off and stick a branch to it. Okay. That's acidic acid. You take that hydrogen off, it becomes acetate, and you got to put something to it, methyl, ethyl, whatever you want, whatever branch you want. Like right here, that's 1, 2, 3. That's propanoate, and then you want to stick a branch. That's cyclopentyl branch. Okay, you got a benzoate right here, the benzene with the carbon with 2 oxygen. That's COO. That's benzoate. It comes from benzoic acid without the hydrogens. And then you got a branch, so that's isopropyl branch. Okay, again, we got another benzoate. Originally, it was a benzoic acid with the hydrogens. When we take the hydrogen off, we put the ethyl in, replaced by the ethyl, so we call it ethyl, and it's not benzoic acid anymore. It's benzoate. something ate the hydrogens. The ethyl ate the hydrogens. You can think about it that way. Okay. All right, guys. So that's carboxylic acid and ester. Amine is a compound with nitrogens, right? So we have tertiary amine. You only see nitrogens. If you see NH, that's a secondary. If you see NH2, that's a primary. For example, here, CH3NH2, that's methylamine. Methyl is CH3. Together, one word, primary amine, because only one branch. If you got three branches, that's a tertiary right there. That's NN dimethyl and propoamine. That's a propyl, okay, and that's amine. And here, this is a tertiary. Both of them are tertiary because nitrogen got three branches. Okay, so that's N-ethyl, N-methyl. Just want to emphasize that they both connect to the nitrogens. And a cyclohexylamine, okay, cyclohexylamine. That's one way to name it. I got some practice for you here. Treat this like homework, okay? Cyclopentoamine, cyclopentan amine. It's a primary amine. 4-methyl cyclohexanamine. Hexanamine means cyclohexane with amine, and there's a branch on carbon number 4. Aniline. Okay, what is aniline, right? Aniline is a benzene with NH2. That's the special name, aniline. And we also get the 2-chloro. Ethylmethylamine altogether. Ethyl, methyl. Ethyl is the whole thing, okay? And it's secondary because it has 2 branches. Triethylamine, you got ethyl, ethyl, ethyl. That's a tertiary. Okay. Now, amine is like ketone and amine together. They have to be next to each other, like propanamide, propane, amine, butane, amine, okay, or butanamide, 4 carbon. Hexanamide, that's 6 carbon. Counting from here, 1, 2, 3, 4, 5, 6. Hexane is like hexane amine, hexanamide. Benzamide, benzene amine. N-ethyl. We want to emphasize that there's an ethyl bonded to the nitrogens. That's what we call N-ethyl. Benzamide. Okay. So basically, you take a benzamide, stick a ethyl on a branch on the nitrogens. You get yourself a new one, right? N-cyclohexyl ethanamide. Ethanamide is right there. The brands always go first, okay? And there's only a few reactions. That's the formation of ester. If you take a carboxylic acid and combine with an alcohol, you get an ester, and of course plus water, because there's too many oxygen here. You guys see it? There's 2 oxygen here, so we're going to take out 1 oxygen and 2 hydrogens, and we make it a water. So it's always going to release a water, and then we form a functional group ester. It's pretty cool, right? Now, if you take an ester, you add water back in with acid. You're going to break them back into acid and alcohol. If you do that with a base, the base will steal the hydrogens from the acid. You form the acid first, but it's going to steal the hydrogen, so you get a carboxylate, the O-. That's the only difference. Okay. Amine, same thing. You can hydrolyze amine. If you do with acid, it's going to form acid, obviously, plus ammonium. If you do with the base, they all need water, and you're going to form a minus, which is the carboxylate plus ammonia. Okay. All right, guys. So that should be good enough for all this compound. And so with that, we got all the organic compounds covered. All right, and then hopefully I'll see you guys next lecture. We'll be talking about biochemistry stuff. That's fun. We're going to apply all this into biochemistry. We want to see how organic compounds work in biology, in the living organisms. Okay. Well, thank you again, everyone, and hope to see you in the next video. All right? Have a good day.